Hi, I'm Kumar, and today in this video we are going to start ICSE Standard 9 Physics. In my previous videos, I have explained second chapter of ICSE 9th class, that is motion in one dimension, and we have finished the discussion of motion in one dimension. The discussion about the motion in one dimension, the branch of physics in which we discuss about that part of physics that is called kinematics. In kinematics, we discuss about the effect produced by a motion. Now, in this part, that is chapter 3rd, we are going to discuss laws of motion. And everyone knows that the laws of motion is given by a very famous and genius scientist who is Newton. So the laws of motion is most famously called as Newton's law of motion, and Newton has given 3 laws to explain the motion of a body. In Newton's law of motion, we are going to explain the cause of motion produced in a body, and the branch of physics in which we study about the cause of motion is called dynamics. And this Newton's law of motion comes under the branch of physics which is called dynamics. And everyone knows that Newton has given 3 laws, and they are called Newton's first law, Newton's second law, and Newton's third law. All the 3 laws given by motion is very famous worldwide and among the students and teachers of the physics. So one by one we are going to explain Newton's first law, second law, and third law. Let me start with the explanation of Newton's first law. For your understanding, I have written a very precise statement of Newton's first law of motion. Let me read this statement of Newton's first law. So it states that when a body is in the state of rest, then it will remain in the state of rest. Then it will remain in the state of rest. Or when a body is in the state of motion, then it will remain in the state of uniform motion in the same straight line unless an external force is applied. Let us understand what is the meaning of this statement. So according to the Newton's first law, if a body is in the state of rest, it always wants to remain in the state of rest. And if a body is in the state of motion, then it should remain in the state of motion unless and otherwise an external force is applied. So every body has a tendency to maintain its previous state, whatever the state it has, whether it is in the state of rest or whether it is in the state of motion. It always has a tendency to retain its previous state. So this is the Newton's first law, and the body can retain its previous state unless and until an external force is applied. Suppose a book is placed on a table, then the book wants to be in the state of rest unless and otherwise an external force is applied on it. So this is the Newton's first law. So every body has a type of tendency to maintain its previous state, and that tendency is called inertia, a very important term which describes Newton's first law. So Newton's first law gives us idea about inertia, and there are so many applications of Newton's first law in our daily life, and we will discuss it also. Okay, what are the phenomena and what are the applications of Newton's first law that is around us. So after the statement of first law, Newton's first law, which gives us the idea about inertia, we will discuss what is the inertia of a body. have seen the statement of Newton's first law, and according to the Newton's first law, every body wants to remain in its previous state. So Newton's first law, which gives us the idea about inertia, Newton's first law gives us idea about inertia. So my very next and very important question is, what is inertia and what are its types? So every body which wants to maintain its previous state has certain tendency. A body has a tendency to maintain its previous state, and that tendency of body is due to its inertia. So the tendency of a body, by virtue of which it always opposes the change in its state, means if you want to change the state of a body, suppose a body is in the state of rest and we want to change its state of rest into states of motion, then body will oppose it, and that opposition offered by the body is due to its inertia. And suppose a body is in the state of motion and we want to bring it into the state of rest, then again body will oppose it, and that is also its inertia. And suppose the body is moving in a certain direction and we want to change its direction of motion, then it also resists us. It does not want to change its direction of motion. That is also due to its inertia. So according to that, inertia are of three types: inertia of rest, inertia of motion, and inertia of direction. So inertia of rest is the tendency of a body which opposes to change its state of rest. Inertia of motion is the tendency of a body which opposes the change in its state of motion. And inertia of direction is the tendency of a body to change its direction of its state of direction or direction of motion. So we have three types of inertia, and this is the inertia which always opposes the change in the state of a body. So what are the applications of these inertia of rest, inertia of motion, inertia of direction in our daily life? We will discuss it one by one. Suppose, let us start with the inertia of rest. Suppose a book is placed on the table. So if no one is going to apply a force on the body, then the body, means the book, always wants to be in the state of rest, and that tendency of body is called inertia of rest. So if no force is applied, there is no one is going to change its state of rest. Inertia of motion. Suppose in a cricket match, bowler is bowling ball. He is throwing a ball towards the batsman, and if batsman is not hitting the ball, then ball try to go in a straight direction. It does not change its state of motion. It maintains its state of motion, and that is called inertia of motion. Inertia of direction. If no external force is applied, then the body will remain in the same straight line. If the batsman hits the ball, then only the ball is going to change its direction. So this is called the inertia of direction. There are so many phenomena that is happening around us which explains the Newton inertia of rest, inertia of motion, and inertia of direction. We will take some of the examples from our surrounding. So, the very first applications of Newton's first law that is taken from our daily life is, if a tree is shaken, then fruits starts falling down. Everyone has noticed that when we shake the branch of a tree, then the fruits which is hanging on it starts falling down. How Newton's first law manifests itself in this application. So let us understand this. Suppose I am shaking the branch of a tree. Then according to the Newton's first law, I am applying a force on the branch of a tree. Then only branch of the tree starts moving. But we are not touching the fruits of the tree. So fruits should remain in the state of rest, and if fruit should remain in the state of rest, then the stem through which it is suspended, the stem starts vibrating. But fruits will remain in the state of rest, and in order to do so, the fruit will detach itself from the stem of the tree and it falls down due to the gravity of the earth. The second example is from the carom board. Everyone has played the carom board at home. So when we put the pieces one by one on the carom board and we hit the lowermost piece of the carom board by a striker, then what happens? The lowermost piece displaced from there and the remaining pieces just fall down. How this happens? How the Newton's first law manifest into it? So when we hit the lowermost piece by the striker, we are applying a force on the lowermost piece. So lowermost piece will be displaced from there. But we are not applying any force directly on the remaining pieces which are held on the top of the lowermost piece. So when the lowermost piece displaced from there is a vacancy created below it. And to fill that vacancy, all the remaining pieces just fall down. It will not move from here and there. The third example in which we can understand the Newton's first law, take a glass and put a card onto it, and take a coin and place the coin onto the card. Now flip the card with your finger. What happens? The card will displace from the glass and the coin which is placed on the glass just fell inside the glass. How does it happen? Because we are applying a force onto the card, then only card will move, and the coin which is placed on the card on which no force is applied, so it will remain in the state of rest. But since the card has gone from there will be no space, there will be a vacancy onto which the coin will not remain, so it will fall down into the glass. So these are the certain examples in which we can see the applications of Newton's first law. So there are so many other examples also into which you can see the application of Newton's first law. So here the application of Newton's first law completes. So after that we will go to discuss Newton's second law.